Okay, so I started a video and it crashed, so I had to start over. So I got some stuff written down here already, but just some examples on how to do some of these problems. Um, I'm just going to give you real generic ones here, so it's not going to match perfect with yours, but this is what printed off when I opened a test. So first off, I have log base 3 of x, and I'm going to look at, well, -1, or -2 in here, but I'm going to graph this guy, and then I'm going to shift it 2 to the right and 2 down, and that's going to give me my graph. Now, since it's multiple choice, I kind of started my graph over here, made some points. Again, this was log base 3 of x, and then I shifted 2 to the right, 2 down, and got something. I was starting to get this shape. And your asymptote here is at +2, so right off the bat, that threw C and D out because their asymptotes are in the negatives. Because again, I moved it 2 to the right, so that gave me an asymptote of x equals 2. Again, we get their vertical asymptote here, x equals 2. And then out of these two graphs, I notice this one's below the x-axis, so that has to be B. We're down and below, so choose B for that one. And then it says, what is the x-intercept for this guy? Or does it not have one? Well, it does have an x-intercept here. It's crossing in there, and if you blow that up on your screen, you can open that up and make it real big. You can see that it crosses, this one crosses at 11, 0. Yeah, if I kept doing points over here with this, my t-table, eventually if I got 9, 2, I go right 9, up 2, go down 2, right 2 from there, I'd be at 11, 0, and that's my x-intercept on the y-axis. So kind of two ways of doing it. If you just blow this up on your screen, make it real big, you can see where it crosses the x-axis. What is the y-intercept on this one? This guy, if you look on this graph, the only way it would cross y-intercept is if your graph got shifted to the left, and ours got shifted to the right, so there is no y-intercept. So we got our vertical asymptote at x equals 2. The domain then would be 2, infinity, and then the range for all of these is -infinity to infinity. Okay. Number 2. That was kind of a long one, several steps to that one, but my number 2, again, I hope he's in the right order. Maybe your number 1 doesn't look like that, but you can click through and find it. Sorry, you might have to fast forward through this video for it to be helpful, but I thought I clicked so they'd all be in the same order. Evaluate this guy. So this is saying that 16 to some power equals 8. You might be thinking, well, square root, but the square root of 16 is 4, so that doesn't quite work. But think, how could you write 16 and 8 with the same base? So I know that these two would work. I could write 16 as 2 to the 4th, and 8 would be 2 to the 3rd. So I got 2 to the 4th to the x power. That's 2 to the 4x power. So 2 to the 4x equals 2 to the 3rd. And since the base is the same, the 2's, it's really just 4x equals 3. So 4x equals 3 divided by 4, and you get, 3/4. So that one is 3/4. Number 3, without graphing, determine whether the function represents exponential growth or decay. So first off, that number right there tells me whether it's growth or decay. If it's above 1, it's growth. If it's below 1, it's decay. So that one is growth because it's above 1. And then the y-intercept, if you're trying to find the y-intercept, plug 0 in for x. It's kind of the fastest way for any function. Or if you remember the number in the a spot right there, because you got y equals a, b, x. A is always the initial value of the y-intercept. So this one is going to be 5. Number 4, see, given these 2 points, write the equation of the exponential function between them. Well, first off, that's not exponential, so throw it out. That's a linear equation. So now I'm trying to find a and b. So I got use y equals ab to the x. So I've got 1.714 equals ab to the -1. I also have 588 equals ab to the 2nd. So just plug in these x and y's in. if you remember, when you have a b to the negative 1, that's the same thing as a over b, which means you'd multiply it over. So 1.714b equals a. Plug that in over here. So 588 equals 1.714b times b squared. So that'd be, which right now I'm just going to, that's b cubed. I'm going to divide this over right now. 1.714. So 588 divided by 1.714. Did I type that in right? 343.057 equals b cubed. Now if I take the cube root of that, the cube root of that guy, and it is, let's see here, it's about 7. I'm not sure, so this must be rounded. Yeah, if I cube root that, it's like 7.0003 equals b, so we're going to say 7. So out of these guys, that b is 12, so throw it out. It's one of these two. To find out what a is, plug it in right here. So I'm going to take b, which is 7, times that, so times 1.714, and it's basically 12. It's like 11.99, so that would be letter D. So letter D on that one. Number 5, I'm going to label these. So now it's same thing as number 1, except it's an exponential now. So if we're going to graph this guy, keep in mind it's the same thing as 3 to the x, but it's going to be shifted 2 left and 5 up. So 2 to the left and 5 up. So 3 to the x, let's see. So I'll make a quick t-table for this guy. Let's see. So 3 to the negative 2 is 1/9. 3 to the negative 1. Oh, my lights just went out. 3 to the negative 1 is 1/3. 3 to 0 is 1. 3 to the first is 3. 3 squared is 9. Okay. And let's see here. So it'd be going something. Here's at 1, 3, 2, 9, something like that. It's going to be shooting up pretty fast. And then I'm going to move that 2 to the left and 5 up. So it's going to be, I know my asymptote is up 5 units. So off the bat, these guys are out. And if I take this to the left, it's going to be one of these guys. It's going to be, letter C. So if you want to move those points, it's letter C. So find the x-intercept on this guy. Well, it doesn't cross. If you look at this, it doesn't cross the x-axis, so there is no x-intercept. The y-intercept on this guy, which if you ever just want to find the y-intercept, plug 0 in for x on this one. So it'd be 3 squared plus 5, so 9 plus 5. So it'd be 14, so 0, 14. The horizontal asymptote, again, I move this up 5 units, so this one would be y equals 5. The domain on this guy is negative infinity to infinity, which is true of all exponential functions. And then what is the range? Well, the up and down, this starts at 5 and goes up to infinity. So it'll be from 5 to infinity on this one. Number 6, the initial value. So I'm trying to find C. The initial value is always that number out front. The growth or decay factor is a number that's inside here. And then the percent change depends. If it's above 1, then it's how much above 1 it is. If it's below 1, then it's 1 minus that number. So this being above 1, 1.02 means it's growing at 2%. So 2% growth. I guess it has a percent sign there. Write the expression, number 7, write the expression of a single algorithm. So if they are both 4, so it'll be log base 4 and be 2 times 128. So 128 times 2 is 256. and now it's asking 256 to the watt power equal, 4 to watt power equals 256. So you could just start guessing and checking on this one. It does end up being 4 times. So if you take 4 times 4 times 4, and obviously don't do it like this, but keep multiplying it 4 times, eventually equals 256, and you can find it. Evaluate the expression without using a calculator. So 16 to the watt power equals 4. And this is one where if I square root 16, I get 4, so it'd be the 1/2 power. So that's a little bit quicker. So this was the non-calculator portion. I'm going to make a separate video for the calculator portion. That way you can kind of speed up what you're looking for. So hopefully this helps. And let me know if you have questions.